Hello everyone, welcome one and all. Today this meetup is for the presentation of Unsupervised Machine Learning Capstone Project. The project name or the we can say the project title is the Netflix movies and TV shows clustering. That is, we have to clusterize or we can say categorize the content that is the movies or TV shows which are similar or which are kindly similar in nature and that we have to make in clusters or categories. Now this project is in nature, that is the type of project is the unsupervised machine learning project, and it is completed individually by myself. And here you can see the overall summary of the project is given here. That is the what is the topic or what is the context of the problem. We can say that the brief information about the Netflix data set, and from the where the data set is collected and how much the files or you can say the data it has, and then the different the data set primarily consists of different TV shows and movies. These are the two major categories, we can say that. And among the similarity between movies and TV shows, we have to make the different categories or clusters for the uh, or for the subscribers or for the viewers. Now, some information like regarding the data set, how much columns it consists of, how much rows it consists of, then which different columns or variables it has. It's given here. Then the some operations we have done to find either there are some null values are there or not, or some duplicate values are there or not. And after that we have found some observations and that are noted here, as you can see. Now as going ahead, we have to make it finish this presentation within 25 minutes, so it may happen that some part of the presentation or this collab notebook I may skip, but you will be provided with this collab notebook link. So whatever you want to see or look over after the presentation, you can take a view from the collab notebook. Okay, the analysis we have made to find some required information or observations. We made it by three means, that is the univariate analysis, bivariate analysis, and multivariate analysis. And what the different findings we have found are noted here. Okay. One note I want to mention here that after making implementation of the different clustering models, that is the three different models I have implemented here. Here, that is the k-means clustering, then hierarchical clustering, and then Bayesian clustering. These three models I have implemented here, and among these three models, the key means model I would suggest here, because I got or I found the seal fault score for the key means is 0.039. That is, we can say that 0.04 as compared to the other two, that is the hierarchical clustering model and deep scan clustering model. Okay, now let's move ahead. Look at here, you can see this is the my collab link here I have given you to access my collab notebook. Okay, now here the problem statement, that is the what the problem actually is, and then with that condition what the solution we have to find, or at what direction we have to move or walk on the way to find the solution. That problem statement is described here. Okay, now some general guidelines are mentioned here. That is the what operations or what things we have to make to find our solution, and what necessary or auxiliary things we have to keep on the way, as given in the general guidelines. Okay, Nick, now let's begin for the further work. Now, first of all, we have to import required libraries. That is the different libraries. We know that we need the different libraries for various purposes and to make our way the different libraries. That is, we can say that NumPy we have required, then Pandas to do some data framework requires, then Seaborn and Matplotlib is required to make some visualizations, right? Then it is a cloud press, that is the we can say cloud word cloud or stop words, that is the we have to make some words to be removed from the data set, right? And cloud word cloud is to depict or we can say visualize the some specific or some more some having some vital important words that we have to visualize or depicts, and for that word cloud library were required. Now some textual libraries to for the some textual data processing and working we have required and that are imported here. Like that we have to we have to import the different clustering models, that is the we can say k-means clustering model. Then the we have to check the score, that is the score of performance matrices versus the performance of the clustering models, that is the we can say which score, for example Silholt score, then agglomerative clustering is also imported here, right? And you can see what other and overall dependencies we can say or required libraries we can say are imported here. Now let's load the dataset. For that we have mounted our Google Drive from the option that is here. You can see once here you get connect and here you can see here are some ways to mount your Google Drive to make access towards your dataset file, and that access is after taking that access and loading that set. We have mounted our drive, and then once we made it, then we can access our data file, and we have taken a view at our dataset file by applying a dot head function. This dot head function gives us the view of the first five rows of our dataset. And as we have applied that function here, you can see the first five rows of our data frame, or we can say of our data set. Now, as like the first five we have seen with the help of dot head function, same in the same way, if you want to view the last five samples or last five rows of the data frame, we use dot tell function, and by applying that function over our data frame, we got the last five rows of our data frame. Okay, in this similar manner, we can also take random some samples from our data frame, as we have taken five samples by applying dot sample in bracket five, right? That is to make take the five samples, and by applying dot sample function, we have taken randomly five rows to overlook the data set. Okay, now let's decide how many rows and columns we have in our data frame. By applying a dot shape function, we can find or we get know how many rows, that is the 7787 number of rows are there in our data frame, and number of columns in our data frame are 12. Now take a brief information about our dataset by applying a dot info function, and by applying that function we got here these are the column names, right? Over here these are the column names, that is the we have different columns here. This 11 number is the index number, and indexing is started from 0. And so we have the total number of columns are 12, and the last one, or that is the 12th column, is the description, and that have the non-null count, that is the non-null values are as 787, and the data type of this column, that is the column description, is object, that is the some objective information is given in the data column or the uh, feature column. Okay, also the size of our data frame is also given here. Now we have make a check here to take a view at the duplicate values. For that we have applied a dot duplicated function, and to take the sum of that duplicated values if there are any, we have applied a dot sum function, and by using these functions we got that we have zero number of duplicated values in our data set. Likewise, we have find we have take a look towards is there any null values have in our data set. For that, we have applied a dot is null function, and to take the sum of any null values if there, we have take a function that is dot sum over the null values, and we got the null values, some of the null values here, this second column for the respective column. And for example, here in the column show ID, the sum of null values is 0. And for the case of the director column, the sum of the null values are 2, 3, 89. And likewise, information is given for the respective column. Okay, and the what is the percentage of null values is there in the respective column is we have calculated here by using this formula, by making the by making a line of code. We have find the percentage of missing uh, the percentage of null values, and here you can see that the column director has 30.67% of null values. Now, the what is the percentage of null values we have in our data set in the respective columns? Here we have visualized, uh, and you can see the percentage of null values is given at the top of the each, and the name of the columns are also given here, and in the form of some visualized manner. Here you can see the bar in the form of white and black lines, right? And these white lines in this bar are nothing but the presence of null values in our that particular column. Hmm? Column in the sense of when we are talking about the data set or data frame, and bar we talk in the sense of the pictorial or in the sense of visualize. Okay, now let's understand about the different variables, that is what the different variables or features we have in our data frame, and by applying a dot column function we got the different variables or features that we have in our data frame, and these are namely show id, type, title, director, cast, country, date added, releaser, rating, duration, listed in description, and the data type is object. Now to describe all the columns of our data frame, we uses a dot describe function, and this include all means it takes inclusion of all the columns that may be numerical or may be objective in nature. and this dot T is to make transpose of the columns. Okay, as time is running out, let me move towards the what different models we have implemented and what findings we have got and what different visuals we have made. Here we handled or we tackled the null values, right? With the help of these outliers. Sorry, I want to say the outliers, not null values. This is the some visualization I have made to picturize the outliers, right? Here you can see the in the column release year, some outliers are here, right? And obviously, I have removed these outliers by making some by using some code that I have given here. And after that, I again visualized the data by removing the outliers. Now here you can see no outliers are present in the release year column. Hmm. Now some feature engineering is made here. That is the some roles that is the objective in nature that we have to make some transitions in that data. Now, after doing some feature engineering, here you can see some new columns or some new variables. As you can say, YY added, added, that is DD added, right? That is the one column we have here. That is the year of addition, right? And that year, that is the nothing but that column we have split it in three different columns. That is the one column will mention separately year, one column mention separately month, one column separately mention separately date. Hmm. And after making this transformation, now the number of rows are 14 here, and by removing some rows that having the null values, right? The new number of rows are the 7770, right? And previously it was, I think, 7787. And what manipulations we have did here, and now what the data is described here in short. Now let me jump towards the different models that I have implemented and what findings we have made. The univariate analysis what is made is given here, and some these pictures or visuals are depicted here. And then biovariate analysis is also made here. And from this pie chart, you can see that that we have a data set that is the Netflix data set, right? And the portion of TV shows on Netflix, we can say that is the 30.86% content is TV shows, and the movies are nothing but the 57% are movies in theater. Okay, and the which country produces the maximum number of movies is given here. That is the United States, and it almost 1847 number of movies are produced in this individual country, and it is followed by India. That is the our Bollywood industry, and also Tollywood is also there. Okay, time is running out. I have to finish it up to 10 7. Very this time we have remained. Okay, let me run towards the models, our models. Uh, Here, yeah, here this is the dendrogram I have depicted here. Hmm. Now the I have checked the score of the implemented model. Here you can see that is the I have fitted a hierarchical clustering model, and then have made a function to evaluate the score of the model. Then this is the score of this that individual model, and at last I have consolidatedly compared the score of performance matrices of all the three models. Let me go towards the comparative analysis or comparative performance assessment. Here we have implemented, as I told you, three models. The first one is that is the k-means clustering model. The second is the hierarchical clustering model, and the third one is the Davis-Scan clustering model. And the different performance matrices we have taken for the assessment of the model performance are the three scores. That is, we have three scores. That is the Silhouette score, then the Kalinski score, then the Davis Bolton score. And by looking towards the score or performance of these three different models, we can see here the hierarchical clustering model having the Silhouette score in negative, that is the minus 0.25. And likewise, the Davis-Scan model is also having negative score, that is the 0 minus 0.25. Both the having almost the same score, and both values are negative. So we can say that the k-means clustering model could, we can say, the better among these three models that have Silhouette score at 0.039. That we can say 0.04. And overall, we can think that is the none of the model have given the good score, but among the these three, on the basis of Poisson score, Silhouette score, we can say the k-means clustering model would be better among the three. Okay, and so I may recommend uh, I would like to recommend the implementation of hierarchical clustering model for this purpose of our project. Okay, now you are you will be available with this my Colab notebook, and anything you need more to watch and to review and to assess my presentation and the project, you can take this link. Okay, thank you.